So again, welcome everyone to RxJS, our second one for 2022. As Mike put it, the reboot of RxJS. So last week, what we did is we looked at solid.js. It was the first time for pretty much all of us to take a look at it. So just a little rundown of what that would look like. It's a lot like React, but like rebuilt from scratch from the ground up. And so a lot of things kind of just work. There's really neat aspects to it. So feel free to check out that video when I put it on my channel at some point. And then we also introduced some coding challenges. So I know Doug shared his coding challenges in the channel. So pull that up. And then I can also show you what I did. And anyone else who has something put in there. I know, what was it? Max was supposed to come as well. Oh, I'm
anxious to see other people's solution. I'm a bit of a JavaScript novice.
Cool. All right, so I am logged into the wrong Slack. I will move things over to the Doug, do you want to take a look at what you've got?
Sure.
Okay, do that. Take a look at it. Negative.com. I really love the setup here. So I was hoping eventually what I'm going to do is actually I have this in a Git repository now, which is more than I had last month. And then hopefully I'll have some like tests that you can run to verify that the thing that you wrote actually does what it's supposed to do. And hopefully my questions will be worded a little bit better so they're not too ambiguous. So the questions for people to review are, and you actually have them here. The easy one, each month will have an easy, a medium, and a hard one. Easy one was find all the characters. I'll actually show you what characters are. The characters are these guess who characters, which you apparently have in guess who characters.json.
Figured out just yesterday how to import the JSON. Up until then, I had it in the JavaScript file.
Oh, not there. Characters. There it is. Okay, so these ones are, I just looked at pictures of the guest characters and wrote these attributes down. I could not find an existing set of them, so these do not have all the attributes. But the idea is we're essentially going to have create a guest Oh, hi, Max.
Hey guys, how's it going?
How you doing? Can you see us
Doing
all?
good.
Oh, hello again. Welcome. There's nothing to see here as well. It's uncomfortable. All right, so yeah, we have guess who characters in this file here. And the idea is that over the course of perhaps as early as this next set of questions, create a sort of guess who solver. So essentially being able to organize these and figure out what is the best way to ask the questions so that you can get a good win the game with guess who perhaps in fewer guesses. So that's the idea behind it. It's not a simple problem. So we're going to kind of do it piece by piece. So the first one was just take a look at all the characters that have blonde hair. And then the second one was create a function that compares two characters and returns the differences between them. So I was a little bit ambiguous here. I said if you just had two characters like Tom and Susan, give them an array of the attributes that are different. What that really requires, of course, is how are you getting those two characters? So you made the assumption here in the medium one that you're doing it by name. So that's what I would have done. Cool.
Okay.
But next time I'll be more clear on what that means. Use a function from the previous exercise to compare each character to every other character structured like the following. So you have the characters that you're comparing to each other, and then the diff that we got for the previous function. Cool. So your easy version here, find the number of bonds. You have a for loop going through, and you're pushing it into a new array with bonds and then returning that. So that looks great. And then it looks like on your other site here, you're actually printing out the result of these things. It's cool.
Yeah.
You have a function at the end that runs all of them and then returns the results of them. That's pretty cool. The second one, character differences, you take the names, you filter and get the first one from each array. And then you go through and loop and check to see if the properties are not equal, and if they're not equal, putting them in a differences array. And I like how you also took out the name.
Right, I think they all have.
Right. So again, another thing that I didn't clarify very well, but clearly they're all going to have different names. So. And then last one here is compare everyone. So you're comparing each character to every other character. You got an I+1 there. That's to make sure that it is not comparing it to itself.
Not comparing to itself, and I figured once you get to number 2, 1 has already compared itself to 2.
Right.
So whichever one you're at, you start with the next one, because all the previous ones have been compared to you.
Right, that makes sense. Okay. Then you take the comparison, create a new object, and then you put the characters in it, and then you diff it with your function that you created previously, and then push the whole comparison object into a comparisons array. So that looks great. Max, you had a solution as well. Did you want to share yours?
Sure. Do you want me to share my screen, or is it easier for you to pull it up?
Sure, you can do that. Let me make sure that you can share. You should be able to share now.
All right. Give me 1 second to pull up that code.
Yeah, well, he does that.
Yeah.
That solution is component.diff method on an object. Is that kind of stuff?
Take a look at it.
It's not diff.
Yeah, so
Just
adding to this initial object that you created here. So we'll show perhaps a better way of doing this. This works fine, but there's a little bit maybe cleaner way of declaring a new object.
Okay,
property.
great.
All right. Next.
Can you guys see that?
Maybe you could use a couple steps larger.
Fortunately, my text editor does not make that easier, but let me see what I can do. How's that?
Yeah, there you go. And I'll move this to the other side.
Cool. So first thing I did was I moved people into a different file. So basically just moved them into an array, and then using ES6 modules, I export it down at the bottom, just keeping it in a separate file. And then for the first attempt, I just used the built-in ES6 function for filtering, and just compared that to blonde, and then just used I guess that's an implicit return when you do the comparison. So that filters it all out, stores it in that new array, and then maps through them and gets out their name, just so we have only the name information coming out. Any questions on that before I move on?
You're familiar with the filter function? The filter method on arrays?
Yeah, I think I actually used it. I think I had to do a little Googling to.
Yeah, filter and map are two of my favorite ways. Map is great for when you're looping over an array, but you really just want one specific value out of it. And then filter is a great way to like do your for loop without having to do an if and a push. And basically whatever this returns out will determine whether or not the filter will include that in the final array. So I did something kind of similar for the first attempt at the medium question, where I hard coded everything. So comparer takes our person 1 and person 2, just using our arrow functions as modern JavaScript. We create our array to store things in, and then we check hair color. If hair color doesn't match, then we push that in for the differences. Same for glasses and wearing the hat. And then finally, we return out the differences at the end. And then I thought I would get fancy, of course, and try and do it using something dynamic. So thinking down in the future of what happens if there are more properties we're storing. So not just hair color or glasses or hat, but what happens if, we add in eye color or something like that. So I use object.keys. And basically what I do is I loop over all of the keys in person 1. And I say, hey, if the key we're comparing is the name, obviously everyone's name is going to be different. So don't count that as a difference. But then use whatever the dynamic key is in person 1 and check to see the key in person 2. And if they don't match, then that must be a difference. So go ahead and return that out. Well, go ahead and store that in the array. And then once you loop over all the keys, store that in the differences and return that out. So these two do the exact same thing between the comparer and the dynamic compare. It's interesting that this one ended up being a couple less lines, but it does kind of set us up for the future of adding in additional keys and having the compare function still work. And then down at the bottom, I tried to get fancy. I wanted to use for the hard question something that would do the combinatorics for us. But basically, I just went on Stack Overflow and found something similar to the other solution where we're basically just doing the outer loop plus 1 to solve for the same problem of we don't want to compare the same people when we go through them the second time. And so one thing that I have learned in my years of programming is never do I and J, because I and J are very easy to lose track of what you're indexing. And whenever you do nested loops, it's so easy to lose track of wait, which one am I incrementing, or am I accidentally comparing the wrong person? And so I try to always name my variables like outer loop or inner loop, or even better, first person to compare and second person to compare, and then just run through that and call our comparer function that we've already written, and then store that as an object with the first person's name versus the second person's name, using a template literal here just so we can store the data easily. And then storing also their differences coming out of the function.
Very cool. So yeah, very similar solutions. I think admittedly I had some ambiguity, of course, in that second question about how to compare two people. So whether to take their name or the person itself. So yeah, very cool. My solution is not very much different. I use INJ. In my loops. So I actually don't have a full written out solution to this third part yet. But I'll show you mine here. Actually, I need to share my screen. Do that. Okay. All right. So in this case, reading it from the file here, this is parsing it, and then there's a little bit of a helper thing that I did here, where I realized that because the name is the ID, I could just pull them out and put them on an object and put the rest of the attributes as attributes of that object. So essentially what happens when you do that is if you were to log out what those what the character object looks like instead. So this one was the JSON that you saw previously, a few characters. So that's what that would look like. The character object instead looks like, oh, you know what? I bet you I don't have a node in here. I definitely do not. Okay. Well, I'll start getting that. Node.js is what it is. Nope, still not Node.js. Oh well. Hmm?
Node.js.
Node-js. Nope. Okay. Not in the store. All right, that's gonna be fun. It's probably like another processing node. Well, I could put this in the console for a browser. But then I have to get on the 30. Anyway, you basically what this looks like is you end up with an array of objects where the name of it is like, for example, Tom, and then you have all the rest of the attributes on it, hair color, and wearing glasses, and the other one was wearing a hat. So in that case, in order to reference it, instead of having to do a filter or a find, I just do a key lookup on the object. So that's just a little helper thing. Without that, originally for the second problem, I was saying a get character function that helped me by using a find instead of a filter. So a filter works well, and then you can grab the first element. You can also do a find, and if it doesn't find anything, it'll return a -1 index. Actually, that's not true. Find returns the actual thing that it found. If it didn't find anything, I think it returns undefined. Is that correct? Something like that. But if there are multiple ones, it returns the first one. Find does. That's what I thought too, but I think that's like the find index there because it returns the thing instead of the index. Yeah, I'm not sure. I'll have to look that up. And then, so mine is very similar to Max's in the terms of dynamic there. If I use a character object, I don't have to worry about filtering out the name because I'm referencing the object that has all the other attributes on it besides the name. And I'm checking to see if it's not equal to there, and then I'm using a reduce instead of a map or a loop, for loop, but works basically the same. So I did not get to doing this one, but I did want to just kind of share a little snippet, an alternative to using these for loops. The for loop works perfectly fine. The definite, or what you would call the thing where you aren't comparing the same thing to the other one, like the reverse, is called like an upper triangle. If you were comparing everything to everything else, it would be a Cartesian product. Technically, upper triangle also includes a diagonal. So this is an upper triangle without the diagonal. But so instead of doing a double loop, this is still iterating over twice. It's still doing the same amount of iteration, but you can use a reduce with another map, which I didn't put in there. The map is here as well. I was trying to make it look a little bit more readable. So this is borrowed from another thing, but it's basically doing the same thing. After creating the upper triangle, you can map over it and run this function and produce the same result as the other ones. So if you haven't guessed already, I enjoy using these array methods, the more functional style of doing things, but just alternatives to solve the problem. They both work perfectly fine.
Is everyone familiar with the difference between like reduce and map?
Probably not everybody.
No,
Okay.
I'm not familiar with reduce. I think I know that.
Yeah, map and filter are relatively straightforward. Map is like transforming each thing in the map, and you'll always get back an array of the same length. Reduce is for everything else. Reduce is where, and it's kind of improperly named, I would say. Often you're reducing your whole entire array to a single value, where that value could be anything. That value could be an array of arrays of arrays. So you could, instead of reducing it, make it larger. In fact, arguably, that's kind of what this is doing. It's not really reducing it, not making it smaller necessarily. But anytime that you are taking each element and you want to essentially run an accumulator function, you want to say, I want each, what you're passing to it is this guy here, this function. It takes an accumulator and then the element. And technically, it takes the index and then the array itself. I needed the index so I could slice it, which is essentially doing that same thing as outer loop plus one. That's what the slice is doing. So then you always have to return something that will be used for the accumulator for the next round. A very common example you'll see for a reduce would be a sum function, which takes an array and then return, well, okay, yeah, then you do array.reduce, oops, not reduce. And this is where you say, okay, I take the first item, which is my accumulator, and then I take my element in the array. And then all I'm going to do is return the accumulator plus element. And technically, it then receives another argument, which is the initial value for the accumulator. If you don't provide it, it will use the first item in the element in the array as your accumulator, which you may or may not want. In this case, it works. For some, this would work. So this will take all of your elements in your array and loop over them and produce a sum of them.
Another question.
Yeah.
What's the difference between reduce and lambda function?
You are using kind of a lambda function. This is just arrow function. It doesn't have to be an arrow function. You can do this instead. You can put function and then open up curly in here. That works exactly the same. So I'm just using ES6 syntax. Then you that was had an implicit return because you're just returning one value. So now you have to return it.
Reduce is like a lambda function.
Reduce accepts a function as an argument.
Okay.
And you can choose to use an arrow function as that function if you want to. Technically, I don't think you can classify an arrow functions as lambdas.
Okay.
It might be. I guess one is going on that. It's just an anonymous
I didn't do enough math for that.
implicit. I don't know. There may be some technical differences, so caution if you're but
Reduce is kind of confusing.
it is.
You see a lot of that functionality, but there's also like a ton of operations you can do.
It is
Yeah, so
a super powerful method. If you're using recursion, sometimes you can replace it with reduce too. Like that's how powerful it is. So I'm actually going to write a blog post that's coming up tomorrow on reduce, so you can check that out as well. Last week's blog post is on map and filter, so feel free to check those out too.
Where you're listening.
Dev.too.
You share that in the slide.
I can. Yeah.
Could you also share your channel? So I can see that first.
Last one, so you
Yeah.
Oh yeah, for sure. Yeah, I'll post the video on YouTube and I'll share that.
Also, do you mind making the fonts bigger?
Sure thing.
One thing that I found is with map, filter, find, and reduce, that students often feel liberated using map, find, and filter. And then as soon as you introduce reduce, it's like an extra layer of complexity where it's like, all right, look, here's this exact same code written as a for loop and as the reduce. And once you get your head around the reduce, it makes so much sense, and that's all you ever want to use. But if you don't understand what the reduce is trying to do, reading the reduce code and actually figuring out what it's doing is really, really hard.
It is. So what's happening in here with this upper loop is exactly the same as what's happening here, but they look so incredibly different. I actually had this down to like 3 lines at one point, and then because you can make them really concise with this. And if you know what you're looking for, it reads cleaner, but if you don't, like, it's nice to have these like helpers along the way to kind of break it up, I would say.
Yeah, I think that's a great example of fewer lines of code does not necessarily mean better code. You know, sometimes more lines of code being more explicit is actually easier to read and ultimately understand.
Right. Cool. Anyone else have any other questions on coding challenge number 1?
So you said you made that out, that data set.
I did, yeah. So I will probably improve the data set so we have more attributes, because right now you can't get really far with in solving it. So I will provide an updated guessed characters list with more attributes. Arguably, it's kind of hard knowing what's considered a valid attribute. Like apparently some characters have like rosy pink cheeks. Some people use it as like, all right, so coding challenge 2 is expanding on that. The easy version is assuming you have the result of this diff function, which I will post as a file. You guys find all pairs of characters that differ by only one attribute. Does that make sense? Okay. Medium 1, write a function that takes 2 characters by name. So you guys should actually put by name in the prompt there. And produces an object of shared attributes. This is almost the opposite of the medium of the previous one, where previously it was asking for the diff of the two of them. This is now asking for an object that is the combination of the two of them. Does that make sense? And then the hard one is basically do all the rest of the stuff. Create a tree of groupings where each leaf node is a character and any parent node is generated by the combined. So basically what this looks like is if you have 2 characters and you take a look at what their similarities are, you can group things together and say, I'm now going to create a new pseudo character that is like the combination of those that has all the things that are similar, but not all the things that are different. So at the top of the tree, you'll have a character that basically is like, I don't care, I have any attribute. And as you go down, you have these different pseudo characters that have attributes that all of its children share. That makes sense. So that's a bit of a stretch. That's a bit of a leap. I really should call hard like crazy hard. It's a lot harder than medium, but if you have questions, feel free to put them in the JavaScript chat as we go. Other than that, we'll jump into our topic for today. Any questions?
Yeah, a hard one.
Yeah. I can reword it to bring some clarification.
I'm just trying to picture it. So you would just create a tree. The data set will be such that there's one at the top, or you say like pursue the generate a tree specifically with all of the characters.
The idea is that all of the characters, I guess I didn't write it down. All the characters are the leaves of the tree. And then at the top of the tree, you have a character that represents any character, essentially. And in between, you would have characters that represent the similarities between all those children.
Having an example output of that might be helpful. Like just showing the first like 3 levels of the tree might make it easier to understand how to generate the whole tree.
Sure. I may actually just kind of put the whole tree as an example. Because writing the function itself to produce that tree will be a challenge in itself. Drew knows exactly where this is from.
Yeah.
So I'm secretly asking you to solve problems for us to work. We're creating a guess who solver here. Not exactly, but it's basically the exact same problem. All right. So we're going to take a look at RxJS today. How many of you have heard of RxJS? Okay, so like half the people. It's used fairly frequently. It came up in the JavaScript Slack. Were you the one who mentioned? No, it was someone else.
I have no idea.
Oh, okay. So I think it was Chris or something like that posted about how Stealth has good interop with RxJS. Of all the frameworks, Angular is the one that's most integrated with RxJS. It's built into everything in Angular. But RxJS is a standalone library for reactive programming. Let me pull up the website, which I have over here. I did a little pre-research on this one because apparently RxJS is notoriously difficult to find documentation tutorials on. So I found a couple that I hope will give us a bit of a start on this. RxJS is an implementation of something called ReactiveX. So this is the RxJS dev website. You can go to the homepage to see what it is. Reactive Extensions Library for JavaScript. The other link that I have in here is a tutorial from ReactiveX. ReactiveX is essentially the umbrella parent for any reactive library in all the other languages. So if there's another language that implements this, it falls under this ReactiveX umbrella. They do say here, let's see, get started here. RxJS is a library for composing asynchronous and event-based programs by using observable sequences. And then they have a little thing here that says, think of RxJS as Lodash for events. Are you familiar with Lodash? Lodash provides some little helper functions, utilities. A lot of them are around like array manipulation. And that's because arrays are really important in languages. But Lodash actually provides things like a map, a filter, and a research. It's built into the original array prototype, so you don't have to use them. In fact, I believe Lodash defers to the prototype method if it can. But essentially, it's these little utility functions that you can use to process your data. RxJS essentially takes any stream of events and turns it into a static array-like structure that's like an observable and allows you to then run operations on it. They often use these marble diagrams to kind of show how different events that happen during time can be kind of grouped together or operated on. You'll see this where it says, okay, ReactiveX combines the observer pattern with the iterator pattern and functional programming with collections to fill the need for an ideal way of managing sequences of events. So it is paired with the functional programming paradigm. You'll also hear a term of functional reactive programming. Technically, RxJS does not do functional reactive programming, even though it does reactive programming and functional programming. So just a technicality, if you're out searching for functional reactive programming, apparently RxJS does not fit the bill. But you see some things like operators, map, filter, concat, reduce. These are the things that we kind of just looked at. Observable represents the idea of an invocable collection of future values or events. Observer is a collection of callbacks that knows how to listen to those values delivered by the observable. The subscription represents the execution of an observable and primarily useful for canceling the execution. You can use observables without subscriptions, but you can subscribe to them and then cancel the subscription at any point. And then the operators are the bread and butter, where you actually take your observable and you can pipe these different functions through them to operate on it. There is this thing called a subject, which is equivalent to event emitter here. It says, and the only way of multicasting a value event to multiple observers. So sometimes you'll see observable and subject used interchangeably. I don't entirely know all the difference between them yet. Schedulers are centralized dispatchers to control concurrency, allowing us to coordinate when computation happens. So as you can see, this doesn't do a very good job of telling me why you use this. And unfortunately, RxJS is notoriously difficult in finding information about it. In fact, the inventor of RxJS is quoted having said, RxJS is difficult to learn. So, and apparently they pride themselves in that. Once you know what you're looking for, the documentation is great at helping you discover new operators you can use. But here's a lowdown of why you would use this. When you are working with an application that has events, and what do I mean by events? It could be user interactions. It could be a person clicking a button. It could be a mouse move. It could be server events. It could be requests coming in, going out. Anything that is considered like a side effect in functional programming, you change into this observable thing, and you look at it as if you know what all of your events are going to be ahead of time. So normally how you would code is you would say, actually, I think they have an example of this. They do. This is a good example. Document.add event listener, click, and then you console log. With RxJS, you would say from events. You would say from events document click, which is basically doing the same thing as saying document add event listener. Subscribe, and when you see an event come in, you say console.log. So this is doing the exact same thing. Why is this better? Well, it's not really helpful until you can actually run the operators on them and look at some other aggregates of your events, essentially. So what makes RxJS powerful is its ability to produce values using pure functions. That means your code is less prone to errors. You can see the functional programming lingo being put in here. Normally, you would create an impure function where other pieces of your code can mess up your state. So in this case, you have let count document add event listener click, and then when you're logging it, it increments that count there. With RxJS here, quite a bit of a jump from just this little guy here to here. We still have the from event, but here you're piping in an operator, which is a scan. The scan operator works like a reduce for arrays, it says, takes a value which is exposed to a callback. The return value of the callback will then become the next value exposed the next time the callback runs. So what's cool here is, here, if I wanted to, every single time someone clicks something, I increment this count clicker so that I have a number of how many times it will click. Here, we're essentially reducing over a future array. So if I had an array that was like, let's just plot some code here. If I had an array that just kind of represented the number of clicks, the way I could kind of do that is say, okay, every single time that the user clicks a button, I'm just going to put another 1 in there. And if I want to know how many times it was clicked, I could use my sum reduce that we talked about right there and figure out how many times it was clicked. That's exactly what's going on here. It's essentially every single time it's being clicked, it's running a reduce function, taking the previous thing and adding to it. So the power here, if you're seeing what's going on, is you're treating all future events as if they've already happened. So you can kind of program in a way where you account for everything that could possibly happen and you treat it as like a static state. It's definitely a different way of thinking about how to handle events. RxJS has a whole range of operators that helps control how the events flow through your observables. This is how you would allow at most 1 click per second. So let's say someone's like clicking a button like crazy and you don't want them to do that. You only want them to click it once per second. This is how you would do it more of an imperative way without RxJS. You would take a look at a date object. There's probably ways to do this without using a date object. You could probably use a timeout instead. But they're really going for how ugly this would look. You take a look at date.now and you subtract the last click, and then you have your rate, which is 1 second there. And you say if it's greater than the rate, then I can log it. Otherwise, don't log it. And then I set the last click to date.now. So that every single time I click it, it's recording this is when I clicked it, and then compare it to the next time that I click. With RxJS, you can throttle it. This is where you're using an operator here. Throttle it by 1 second. You're doing the same thing with your reduce, your scan, and you're subscribing and you're counting. So this will do the same thing as way back here, but now it only lets you click it once per second. So I think this is actually a pretty good example of how RxJS helps handle events and future-based things. Values. You can transform the values passed through your observables. Here's how you can add the current mouse position for every click in plain JavaScript. So what if every single time you click, you want to record where on the screen it was clicked? Here you just grab client X, and then you add it to your count. That's what they're doing. Here, they're just using a map and taking the events, grabbing the client X off of it, and then piping that into the accumulator, and it will then add the client X to the count.
So the pipe is a process, it's an array of operations. And you send that event through.
Right. So
First, you draw it, and that opens out anything that's not. Second, then you map through the clicks, and you scan.
yeah, so pipe is
Very
takes,
functional.
yeah, very functional. Like Elixir. Elixir literally has a pipe operator where you take the thing, the result of that gets passed in as the arguments to the next one. So it looks like what gets passed in to scan, well, scan, I suppose, technically taking your array and passing it as the calling, like if it's a reduce, you're calling like reduce calling the array to get back to scan for map, sorry. Other value producing operators are pluck, pairwise, and sample. Okay, so I missed what I was saying. Value producing. So the map function is a value producing operator, as opposed to scan, which is not producing it. Okay. All right. So that's as far as I get with the documentation here, pretty much. I mean, you can get into observables, and it actually is. It's not that bad. All right, let's take a look at observables. Observables are lazy push collections of multiple values. They fill the missing spot in the following table: pull function, iterator, push, promise, and unit. Okay, so if you're pulling something, you can use a function. But if you're pulling multiple values, you want an iterator. If you're pushing something, you want a promise. But if you have multiple things, you use an observable. So that's just kind of what the function, promise, and iterator are all native JavaScript things. Technically, observables are now too, but RxJS provides their own version of observables with all these other extra things. I believe observables are native now, as of like ES6. I don't know that. Following is an observable that pushes the values 1, 2, and 3 immediately, synchronously when subscribed, and the value 4 after 1 second has passed since the subscribe call. So you can create your own observables if you want. This one basically says, take a subscriber and call next on 1. This looks very similar to how you would actually create an iterator if you wanted to, or technically a generator. And so what's happening here is it pushes 1, 2, and 3, and then after 1 second, it pushes 4. So if you were to subscribe to it, subscriber complete. To invoke the observable and see the values, you need to subscribe. Okay, they just added this extra stuff. So you subscribe to it. You call next x, you get got value x. If you get an error, okay, so what you're passing to subscribe is an object with 3 methods on it. The next one will always be called when you get a next value. If anything goes wrong, it calls the error method. When it's done giving you the values, it calls this complete method. So this is what you get. Just before subscribe, just call it up here. Value 1, value 2, value 3. Just after subscribe, then you get value 4, and then you get done. You see what happened there? So what happened here was, because this was a future thing, we didn't get the 4th value because it was sent later. It was sent asynchronously until after we had done this conf log. So similar to how you to promises, where if you say I'm going to get a value, and then you continue on with the program, and then you'll be until later that you're processing the value that you got back. Pull versus push. Pull and push are 2 different protocols that describe how a data producer can communicate with consumer. Okay, so basically this is saying you can choose to request a value from something, or you can choose to observe something, and when the values come, you get notified by them, basically using a callback. Right? So this is kind of explaining that table that's up here. They're saying that a function is lazily evaluated computation that synchronously returns a single value. A generator is lazy evaluation computed that synchronously returns 0 to potentially infinite values on iteration. Promise is a computation that may or may not eventually return a single value. An observable is a lazy evaluated computation that can synchronously or asynchronously return 0 to potentially infinite values from the time it's invoked on. So this is pretty dense. I'm going to see if they have a better example with some of the Marvel diagrams or something like that. This is Marvel testing. Let's take a look at the other. It looks like this is just that. Or literally have, is it in here?
No, you just said earlier it's RxJS.
It is hard to learn. It is super powerful though. I was hoping that I could find, oh, here we go, Marvel diagram. There we go. So this is where it gets fun. And I wish that they kind of started with this because the visual really helps see things a lot better. So they kind of explain an observable as this timeline of marbles. Kind of like an array, has a whole bunch of stuff in it. So this is time flowing from left to right to represent the execution of the input observable. These are the values emitted by the observable, and the vertical line represents the complete notification. So if you have an operator that says multiply by 10, you take each one of your things, and you, this is like a map. You take each one of your things, you run some function on it, and then you get a new Marvel diagram. But if something you couldn't multiply a by 10, so you get an error instead. So choose an observable. Oh, cool. Does this have like a, yeah, let's try looking at the throttle one that we saw already. Throttle. Oh, that's like the entire tutorial is in a single page. I don't like that we can look at that. Probably. Okay, so let's see. Let's see this throttle on this list here. Here it is. Okay, so this is the throttle looks like. Remember how the point of it was to make sure that you could only click once per second. If we see these events A, X, and Y are too close to A, and then we see B and X. X here is too close to B here, and then C, X, X, X. These guys are too close to C. So throttle says, I'm going to get rid of the things that are too close to each other. And it just does that for you. So it transforms this list of events that were too quick and just says, okay, I'm going to give you a new list of events that only does it once per second. It doesn't guarantee that they're going to be a second apart from each other. It just guarantees that they're not going to be less than a second apart from each other. It could be more than that. So that's what throttling is doing there. Do we have other good examples? Let's see if we have another operator we could look at. Let's take a look at how scan works, because that's basically a picture of how reduce would work. Okay. So scan is accumulating values as we go. This is 135. This is 149. That's where you took the first event. Then you added the second event to it to get this second event. Then you take the third event and add the second event to get the third event. That's exactly what reduce is doing on the arrays. It's taking each element, your accumulator, adding it to each item, and going and keep adding as you go.
Yeah, I feel like the reduce function feels very much like Haskell, the folder L. I don't know if anyone has done that.
It is.
Folder L. Very, very similar.
You're right on the nose. So technically, the reduce is an implementation of something called a foldable. So yeah, it's doing exactly that. It is full L, yes, from left to right. For people who know Haskell, which is probably only you. So yeah, reduce is a foldable. Technically, a map is a functor. So if you see, well, actually, Haskell is called map too.
So accumulator is the result on the bottom, and then current is the top. So you're taking top, adding it to the next result, and the next top.
Yep. So you're taking whatever you end up deciding to return here gets used as a value that will be passed into the next accumulator. You'll almost always see that being used as an addition. They don't have to be additions. I'll see if I can pull up some good examples I'll put in the JavaScript side. I used a accumulator one time that used Boolean comparison. You can use comparators if you want to. Let's say you had like a whole bunch of filter functions that you wanted, and you wanted to make sure that all of the conditions were true. You could reduce over all your conditions and make sure that when you compare true and true, it's still true. If you ever get a false in there, everything else beyond from there on comes a false. So that's how you could input essentially all function. You know, if you have array dot all, you want to make sure that all the things considered are true, you could do that.
What's the zero going?
The 0 is the initial value to the accumulator. So the accumulator needs an initial value. In JavaScript, for reduce, if you don't provide it, it uses the first element. That's what's going on there. So I think we're running out of time for today. This is very brief intro to RxJS. I'm going to see if we can find some better examples of where this would be practically useful. It's used all over the place in Angular code bases. So maybe you can ask Peter Smith for some examples of how he uses it. But I also like to see perhaps examples of where this is used in React or some other frameworks. It doesn't have to be used on the front end. You can use that in the back end as well.
So mostly anywhere where you need fine-grained control over events.
Yes.
So for instance, like mobile apps, more complex, lots of tabs, sorts of web designs. And I think code people use it for games and manipulating like JavaScript and technically that's that way. But anytime that you need like a high degree of control over your events, it's useful. It's useful.
Yeah.
It's just a big overlap.
It is.
If you start having to like think about like observables, what is observed, like and moving things around.
Right. I think the most powerful thing, and it really has to be done in a functional style. So you can't really use this without also knowing how to do programming. The most useful thing that it does is it transforms all future things into as if you already know all of them. So you can operate on future events without already having them, as if you already have them. And that's kind of the power of RxJS. Cool. Any other questions before we wrap it up for today?
I still don't understand about, you say the future events. Can you give another example when, like future events?
Yeah, so I think these marble diagrams kind of illustrate it well. When we look at this, we kind of see this as I'm just operating on this to transform it into that. But when this actually occurs in your application, this thing hasn't happened yet. This thing that you got, you haven't actually received it yet. But you can operate on it, you can reduce on it, you can map on it, you can, any of the other operators, you filter, you can throttle, as if you already had it.
Is that like an easy evaluation? Is that like same thing?
Lazy evaluation. Yeah, I guess you could kind of call it lazy in the same sense that like generators are lazy.
Right.
Yeah.
So when say it'll happen with future events, so the results come in as the events happen?
Yeah. So when an new event comes, it gets piped through all of your logic, and then you're notified of the result if you want to be notified, right? Because essentially the alternative to like throttle was that this guy's in the way here. How can I go through that time? It's very much in the way. This is really fun. Yeah. There's like no way of like moving them. There we go. Okay. put that back up there. Okay. What was the observables one here, right? Sorry, the question again was about the throttle thing. So in the overview, we're taking a look at how it does throttling. The alternative to throttling, just a single thing of saying throttle one, is wrapping it in an if, checking to see if the events happens after a certain amount of period, and then only if so, now you care about doing the thing. Imagine replacing this console log with whatever you want to do. Okay. Here, you don't even get notified about, like, you don't even get into this like event. You don't have to worry about handling this event if you don't care about it, because this has already done the throttling for you, and this function will only ever get notified if it's already throttled. So you end up only like getting the event you care about. I was thinking actually kind of doing an example of this, but I didn't have time to pull it together today. Imagine that I have an event that's listening to mouse move. So I have document.add event listener, and then this mouse move. And I only care about whether or not my mouse is on the right side or the left side of the screen. That mouse event thing gets fired like super, super often. You'll get tons of these events piping through, but you can just put a little pipe operator here that maps it, and then checks to see if it's on one side or the other, and then combine. I'm not entirely sure what the correct operator is, but there's a way that you could basically only get an event if it crosses from one side to the other, and then only get an event if it crosses back. And so you could do that with just a couple operators in here, whereas you would have to essentially like handle every single event and then check to see if it was within a certain boundary, and do a lot more work to do that. Cool. I think the people who were interested in RxJS and JavaScript didn't attend today, so we'll put this in the recording on YouTube, and hopefully it's more useful. I'd actually be very interested afterwards to hear from those people what they want in RxJS and where they use it, because I know Chris posted it in Slack and said that he enjoys using it with Salt. So that'll be really interesting to hear about. All right, any other questions and other comments, thoughts before we close for today? Kind of like Reddit.
Yeah, thanks for sharing that. I didn't know.
Cool. All right, well, we'll wrap up the recording for today, and thanks everyone for coming.
Thank you.
Thank you.
Stop recording.